Hi everyone, thanks for tuning into another episode of D Industry. In this episode, we have a very special guest with us. This time, it's not a designer but a data scientist joining with us. Hi Tejan, welcome to D Industry.
Hey Ravi, thank you so much for inviting me. It's been an absolute pleasure to be a part of this. Thank you so much.
Thank you so much, Tejan. So, how was your day so far?
It's been a pretty interesting day for me. I think I've been doing a couple of things that were on my plate, and I'm also kind of preparing for a couple of workshops that are going on that will happen in the upcoming weeks. So yeah, just trying to juggle a couple of things together, and yeah, I think really geared up for this podcast. That's I'm really hoping to have a lovely interaction with you.
That's really wonderful, Tejan. So, in today's episode, folks, we're gonna talk about AI, and Tejan is a data scientist. He's gonna introduce himself very soon. So, but in this episode, we're gonna be like fully packed on the conversation related to AI. So, Tejan, before we get started, why don't you introduce yourself to our viewers out there?
Sure, Ravi. So, hi everyone. I am Tezan Sahu. I work as a data and applied scientist with Microsoft. It's been approximately a little more than 3 years since I joined Microsoft after graduating from IIT Bombay with a majors in mechanical and a minor in computer science. Beyond my work, I'm also an Amazon number one best-selling author for my recently published book, Beyond Code. It came out last year. And along with that, I'm also the co-author of an AI newsletter, which is called The Vision Debugged. And just to add to that, I think I love sharing a lot. I think sharing stuff, sharing my experiences, sharing a few tidbits that I'm learning all the way. So I'm pretty active on LinkedIn as a content creator, and I'm also sort of a pretty active mentor on TopNet. So yeah, that's about the professional side of me. Beyond the professional side, I think I am a lover of the arts. I love to paint. I love to sing. And I'm also pretty passionate about racket sports of any sort. I love playing table tennis. I love squash, badminton. So yeah, that's a bit about me.
That's wonderful, Tejan. Thank you for sharing it with us. So let's get started into our episode. So to a layman who is watching this video, now that everybody knows what is AI, could you tell us how does actually an AI system or an AI product work?
Okay, so to understand artificial intelligence, let's just take a step back and think about how human intelligence works. Now, just imagine with that big complex brain of ours, how we are able to perform various tasks of various difficulty levels, all at some point of time very seamlessly. Now, if we try to emulate this functionality of our brains and see if we can pull those learnings and techniques and add them into computing devices. Let's say computers. Today you talk about GPUs. You talk about any other hardware, and see if these machines are somehow able to accomplish tasks of similar levels, or or sometimes even tasks which humans may not be able to do at that greater level. Or that is something which encompasses artificial intelligence, and we call it artificial because it's typically emulated by seeing your human brain the way it functions. It's not typically the entire brain functionality, but a lot of these nuances that we learn from neurosciences, neurobiology. I think all of that somehow translates into computer science, and then you're able to build products or build agents which can accomplish certain tasks in probably ways which even surpass human abilities at times. Now, that's what AI is all about. Uh, I think since most of us have been hearing about AI for a long time now, it's been mainstream primarily since the kicking off of ChatGPT or almost 1.5 years ago. And I think with hearing AI, we've always heard these terms like machine learning, deep learning. So just think of these as various tools in a toolbox which power an AI agent or an AI product of sorts.
That's very
So
wonderfully
that's a very
explained. Yeah, I totally agree upon that. And now let's talk about, whenever we talk about AI, we talk a lot about GPU and power. So, what exactly is the role of GPU? And people also wanted to know how NVIDIA is growing up day by day in this AI wars that is happening. So, what exactly is the GPU's function in an AI product?
okay. So these machine learning models or the deep learning models which we say to train to achieve a particular functionality through artificial intelligence. These tra- the, this training and this entire training process involves a lot of heavy amount of computations. It's all math going on in the background. So a lot of complex things. So I'll not bog you down with the mathematical details. But just think about it that there's a lot of heavy mathematics that's going on in the background, which a computer needs to do. Uh, if you burden a single CPU with or a single processing unit with all of that training process, it might take years and years and years, even billions of years, to achieve even the smallest of tasks possible. So I think researchers came up with some really smart ways of parallelizing these most of these computations. And they've been very smart. I think every now and then you have multiple research papers trying to come up with lots of optimizations, lots of different form of parallel ways in which these string of computations can be distributed and all the computations can be done in a much more efficient manner so that this entire training process for models can happen in a very short amount of time. So GPU is a piece of hardware which supports such vast degree of parallelization and enables these various machine learning or deep learning models to get trained in a much faster period of time. And when I say faster, it for these large language models like ChatGPT, GPT-4, all of that, I think it would still take days to months for training, and that is the lesser amount of time. So just imagine if we did not have GPUs, how much time it might have taken. And today, I think you mentioned about NVIDIA being a market leader as far as GPUs and these these computing devices related to AI models is concerned. I think rightly said, because the only reason why NVIDIA has risen to such a high market cap is because it is a leader in creating these GPUs, and not only GPUs, it's come up with a lot many new devices, or it's in I think in its showcase in May, I think they proposed a bunch of new innovations in this space, all leading to its stock price skyrocketing without any uh, formal competitor of sorts. It's basically a monopoly in its space. There is no viable competition. I mean, there are certain players out there who might come up with something here and there, some processors, etc. But the way NVIDIA has been dominating the space is absolutely phenomenal. And all the tech giants, be it Microsoft, be it Google, be it Amazon, all of them require these hardware for training and making their models better and better and better in this AI race. So in the end, it's finally the producer of these chips or the producer of these hardware devices that gains the maximum from the entire AI battle that's going on. So I'm not sure if you've seen this recent meme about the gold rush sort. It's basically a gold rush sort of a meme wherein everyone is coming to a shop to get a shovel to dig the gold. The gold is the AI, and the shovel provider is Nvidia basically. And think of the shovels to be your computing hardware.
That's very well explained. So we often also hear this term LLM. So to a layman, what is exactly LLM, and how are these models usually get trained?
I see. So LLM typically stands for large language models. So language models come into picture where uh, language models basically come into picture when you are dealing with textual sort of data. Now, think about how we as children have learned to speak or learn to frame sentences. Uh, as kids, we knew the meaning of different words, started learning them. We started to put one word in front of the other so that it started making sense. And that's how, in some way, we learned a particular language. We added new terms to our vocabulary, and we tried to understand where what is the right way or right position to put that word in a sentence. I think so that it makes sense and we can convey information in the right way possible. Now, in the broad scheme of things, language models are a way of trying to understand or model the way a particular the semantics of a language work. Now, I think the birth of language models had happened long before this wave of GPT and ChatGPT. Uh, there were very early on models which could basically be predicting the most likely next word after a particular string of words or particular string of characters for that sort. And with this philosophy itself about what is the most likely word that comes next, we started optimizing or basically trying to come up with different architectures of these models or different ways in which various components of these models are connected so that they can make much better predictions of what word comes next or what and how the next sentence is formed. So that's when one of the seminal papers was released about BERT or bidirectional encoder transformers. We started we started encountering this term transformers back, I think, in around 2018, 2019 of sorts, became really famous. And that brought in this concept of attention. Now, before transformers came in, the way these models used to be trained or used to basically look at how the next word is generated is basically just look at the sequence of all the things that have happened in the past and generate the next most probable sequence. But with the advent of this attention mechanism and transformers, we started to weigh these various components of whatever has come before indifferently for the next word that is predicted. So, for example, think about these two sentences. The cat is on a mat. It is sleeping. So, if I have the sentence that is the cat is on the mat and with a full stop, and I want to predict the next thing. So, the next word is going to be it. Now, what does it refer to? It correlates very highly with cat, which has appeared long back in the sequence. So to predict that particular word, I think the model would, instead of just blindly following the previous token or just the few previous set of words that have come in, it would be very important for it to attend to or know the fact that it would refer to the cat, which has happened long before in the sequence. So to capture this sort of a dynamic, this attention mechanism came into picture, and that is that's the key concept that powers transformer architectures, to which have become I think they've become a cornerstone of language model development. Now, with transformers, we were able to develop really cool models which could do classification, text classification, like classifying different sentiments of review or different reviews into multiple sentiments, or basically even convert some sentences into a different language through translation, or achieve a bunch of other tasks. And slowly, we wanted to accomplish even more. We wanted to see if we can get the capabilities of these models even better by making these models larger and larger, more powerful of sorts. And that is when we encountered this realm of large language models. Now, What large language models are is basically just take these transformer models, probably just scale them up to a severe several thousands times, and connect them in various nuanced forms in the form of different architectures, and try to see if they are able to understand, hold the semantics of the language that they have been trained on, and if they can generate something really cool. So that is why these large language models are able to take a lot of context in the form of prompts, which we know they are basically instructions as to what the context of this task is, who I should do the task for, how I should behave, and then eventually the task. And then finally, when I know the context and I'm passing it to this large language model, it understands, it uses the knowledge that it has already gathered during its training, and gives you much more refined outputs, which are really, really beautiful. And almost now they can be very hard to distinguish from even human text that humans write.
That's really wonderful explanation, and I really like that example with which you have explained this. So, Tejan, we have spoken about AI, we have spoken how does this thing work, we have spoken about LLMs. Now, let's talk about AI in India. So, what's your take on how is the AI development happening in our country?
So I think we have had some phenomenal development as far as these large language models and AI is concerned in India as well. Although I think many people are aware of these hyped LLMs like ChatGPT or Gemini or Claude, which are all internationally available. But I think we should never not forget that there have been some really, really cool advancements in our Indian LLM market as well. So, just to exemplify, Ola has come up with its Krutrim model, which I think is very, very similar to how ChatGPT works. It's basically a chatbot. You can ask it questions. It gives you well-formed responses. The good selling point about these Indian LLMs like Krutrim is basically they can work with Indian languages as well. I think, if I am not mistaken, there's Krutrim, there is Hanuman. So these are models which work with almost 10 to 12 different local languages. I think it works with Telugu, Odia, Hindi, Malayalam, and a bunch of other local languages, which is pretty phenomenal. And honestly, I read this article a while back wherein when Sam Altman once came to India, I think during the boom of ChatGPT when it was just beginning to come, I think he was asked about what his views about Indian LLMs is, or can India compete. So I think it was a very controversial statement that time. It brought up a lot of eruption around the fact that he just said that it's better that India doesn't compete with in LLMs because they don't have we might not have the amount of the entire capabilities or the amount of computing resources for that matter. So that's what they came up with. But I think we have been able to prove most of this wrong. Today there are some really cool organizations like I think AI for Bharat and a bunch of other organizations which are so passionate about building these indic LLMs of sort. And in Microsoft also, I am fortunate to get a chance to interact with and talk to and learn from people, researchers, applied researchers who have worked very closely with these organizations, with institutes like IIT Bombay, IIT Madras, and a bunch of other IITs and NITs to make significant progress in the way Indian languages are used to construct LLMs. And today, I think we do have some pretty interesting LLMs that are out there. Krutrim and Hanuman are definitely some things to check out. I think there is something called as Eravat as well. And beyond this LLM landscape, I think there are a lot of Indian startups which are somehow using these AI capabilities to come up with some phenomenal product ideas. I think every time you go on this website like Product Hunt to see what are the top AI products or stuff that's trending out there, I think I am always fascinated to see at least one or two AI products which are Indian homegrown products uh, in the top 10 or top 20. So it's really heartening to see those. And we are not limiting ourselves to software. I think I came across this very amazing product, which is sort of an AI chef. It's basically a hardware device. It's like your mixer grinder. It's created in India, and this was also the founders also pitched themselves and their product on Shark Tank recently. Now, this AI chef is basically something wherein if you select if from the panel, if you select the kind of dish that you want to prepare it and provide it with the right ingredients, it will do all the chopping, it will do all the cooking, etc., in a matter of time, which is probably uh, less heard of for humans as well. So it will prepare the entire meal for you, and it will also rinse itself later, so that you don't need to worry about the cleaning part as well. So it's all in all an AI chef, and you can also introduce new recipes into it. So that's pretty phenomenal as an idea itself. I love to see the fact that we are not just restricted to software side of things, but as Indians, we are using these various AI technologies to build a lot of these hardware products, which are actually solving real life problems.
That's some really wonderful examples. So Tejan wanted to understand if somebody wants to learn more about AI and if applications of AI, or you could say, for anybody who is budding down there, like still in college but want to explore, what's the path they should follow?
I see. So there are two ways to, I think I've always stressed on the fact that there are two ways of learning AI. One is definitely if you want to get into the field or somehow just be aware of things, you need to know the fundamentals very strong. So one way is to one path that you should follow if you want to venture into AI is to build strong fundamentals. So for that, I think Microsoft and Google have both launched several free courses out there. There are also a lot of courses which are available on this website called Deep Learning AI, which is all in partnership with Andrew Ng. There's some really, really cool courses to get you started with what is machine learning, what is deep learning, what is AI, what is LLM, how do you use various LLM frameworks to code stuff, to create AI agents, how can you use low code and no code tools to build AI agents. So there are a bunch of courses about all of them. Maybe we can link a few of them in the description of this podcast. I'd be happy to do that. That's definitely one way, one path wherein you are strengthening your fundamentals. The second path, which I think is much more nuanced and much more interesting, is that AI is such a dynamic field that every day or every week you're coming up with new models, new products, new technologies. The landscape is changing very frequently. So to stay abreast with all these technologies, all these new things, I think some of the best ways are to listen to podcasts or read AI newsletters. I think I am a huge fan of a couple of AI newsletters. They are like one of them is Superhuman, the other is the Neuron Daily, and these are two newsletters which are published daily, and they definitely keep me updated about the latest happenings in the world of AI, be it some extremely new model that has been breaking the internet, or be it some investments that have happened in the AI space, or just some fun tools to play around with. So that's a way to keep your minds really sharp about what's the latest in this tech. And if it interests you, because we have seen a lot of interest that people love to explore these various tools or the various technologies. They get a gist of it through these AI news articles, etc. But one thing which they struggle to know is what, at least one step deeper, as to how did this happen, or what is making this thing happen. So we've gauged a lot of, I think me and a colleague of mine, we gauged this interest a lot about people wanting to dig slightly deeper into the mechanics of what goes behind AI. But due to the sheer volume of information or the sheer complexity, people just stay away from there. They are a little apprehensive about venturing into that. So I think I think me and a colleague of mine, we came up with this AI newsletter of ours called The Vision Debugged, wherein we try to explain really cutting edge AI research and AI products in simple bite sized terms without too heavy jargon. We try to break things down as simple as possible into interesting visuals and simplistic explanations to so that even you as even a non-technical as you as a non-technical person who may or may not have too much of experience with the deep learning side of things or machine learning side of things, you can still appreciate what's going on in AI, be aware of them, and also use it to your advantage wherever possible.
Thank
I
you
think
so
these are some
much.
definite ways to.
Yeah, man. Thank you so much, Tejan, for sharing these wonderful resources, and we'll also list them onto the description along with Tejan's newsletter as well. Tejan, what steps should India take for its future development with use of AI?
I think that's a very interesting way of looking at things because I think we have been progressing so fast and so rapidly. The entire world is looking at things so rapidly in this particular space. And I'm pretty sure the advancements that we are doing in India are no less. So, one thing which I definitely feel we should start doing a little more is integrating the awesome research that's going on in these amazing facilities like IIT Bombay, Triple IT Hyderabad. I think they have, I mean, these are institutes which are doing some really phenomenal amount of research in a bunch of different AI spaces, be it natural language processing, computer vision, multimodal models, looking at low resource languages uh, for various transliteration purposes. I think they are doing a lot of amazing research. They're publishing across really top A-star conferences across the world. Now it's about taking that research and trying to infuse that into real products that can really, really hit home. They really penetrate and bring AI into the hands of a lot many people. That's definitely one angle which we should focus on more than what we are doing right now. There are a lot of companies who are partnering with research institutes. I am aware of Microsoft having this Microsoft academic grant, wherein we partner with top a bunch of top institutes across the country and do collaborative research around areas which are of mutual focus, more mutual interest, and try to incorporate them into our products. I think similar approaches should be taken by a lot of these startups, a lot of these typical AI startups which grow out of Bangalore, Hyderabad, Bombay, a bunch of these tech hubs in India. I think should start building that cross connection network, try to infuse this knowledge and see if something really cool can come out of it. That's one major thing that I would like to advocate for now.
Those were some really wonderful recommendations, Tejan. So, how do you think AI is transforming some of the core things like agriculture, pharma, or logistics?
I think the fact that AI has not left these particular core areas untouched is a testament to the fact that AI is bringing a lot of revolution. So it's not just restricted to, let's say, the world of marketing or coding or software development. I think AI is truly here to democratize uh, bunch of these core functional areas as well. For example, I think the way we have advanced from very primitive predictive modeling techniques to really advanced models of sorts, they are really transforming the way we are able to do demand forecasting and inventory management in a bunch of these small to medium scale industries as well as large scale industries. I think predictive modeling is helping a lot over there. Second, I think the way we rely on cloud infrastructure for most, and I think many of these small and medium scale businesses rely heavily on a lot of offerings from various cloud providers, be it Azure, be it GCP, be it AWS. And resource management in the cloud is something which people may not be familiar with a lot. But with AI being infused into these cloud platforms, these top shot tech companies are trying to offer solutions wherein the consumers are able to monitor, they're able to get a lot of cool insights about how their resource utilization has happened and how they can make it better or optimize for more savings or more utility. all of those kind of services are really helping streamline a lot of these functionalities. This is about logistics, industry scale. Now, if you come to farming, I think farming is also something which uh, it's typically the bread and butter. It's the majority of what India does. And if we are able to crack AI in farming, I think that's going to revolutionize things a lot. Now, what I see today is that the way farmers are using AI is uh, through let's say localized or multilingual chatbots. I think we do have certain providers, like even I think Azure is providing certain services which allows you to converse with AI agents in your local language. I think that is probably helping farmers a lot. Dedicated apps which can help you help predict the kind of requirements that will come up, or the kind of training that will be required for you to do a particular farming job in a better way. Those things, those services that are offered by these chat facilities is pretty amazing. A little slightly offbeat. I won't say totally offbeat, but yeah, it's slightly applied form of AI which can also help farmers a lot. Is that we know that the farming community of India typically relies a lot on forums and a lot on YouTube videos to learn a bunch of things, be it about the latest stuff that's the latest grains that is in the market, or the latest technologies that are being used, or basic how tos in the farming domain. Now, with a lot of these AI tools that are out there, I think you have tools like Merlin AI, you have a bunch of other tools which can actually not only transcribe YouTube videos, but actually extract a lot of insights and allow individuals to chat with videos to understand a lot of nuances about these videos as well. If we are somehow able to get all of this thing in local languages, that will fuel a lot of these farming communities, because English will definitely be a second language to them, or not even the second language, I think. But still, farmers who know English can definitely benefit a lot from these existing applications. But if there are actually startups who are addressing the core need of converting, let's say, converting these English transcripts, so that into local languages, so that people can converse with them, learn from them, and that is also a pretty big opportunity in which AI can help the farming community of India. So I think the major challenge that lies ahead, I think it's typically about addressing this concept of low resource languages, because several languages like maybe Assamese or very things which are tribal languages, but still spoken in some very very interior regions of India, probably. Those are things wherein you don't have a lot of literature for models to get trained on, and that's one of the major hindrances in developing such tools. But I think we're coming up with some really amazing research to look at low resource languages, how to enhance their quality, how to do certain mappings to increase their volume and use them in certain applications. So yeah, really looking forward to those things going into actual production and causing an impact.
Thank you so much, Tejan. So before we conclude, wanted to understand your take or your vision on how AI will evolve in India after 10 years from now.
I see. So, to be very honest, thinking about what will happen 10 years from now is something which I would not want to do, because the sheer pace at which we are moving, I think if I envision something for 10 years, it is very likely that we achieve it in the next 2 years. It's highly likely. No one had ever imagined the kind of AI powered videos that we are getting today, about images that we're able to get today in such, let's say, 5 second latency, 3 second latency. So it's really a powerful way in which we are going ahead. But looking at the future, I think there are a couple of things which need to be addressed for sure to make AI much more accessible to people, and that's the way. That's the direction in which people have started focusing a lot on. So one thing is the core focus on sustainable AI. Second is about responsible AI and governance. I think these are two areas which I believe need to mature a lot over the next few years, so that we can make unprecedented progress in making AI much more accessible to people and allow more and more people to get into the ecosystem and build something really more interesting. So, as far as the sustainable part is concerned, now we know that I think early in this session we were discussing about how difficult it is to train these models on normal compute power. You need dedicated compute in the form of GPUs, which are only probably produced by very few industries or top producers out there like NVIDIA. However, to let's say bring AI to the masses, suppose you want the capabilities of that very large model, the functionalities that it is providing in your probably something like a wearable device like a smartwatch. I mean, today smartwatches do some really smart things, but still, I think you can't expect a chat GPT sort of a response from a smartwatch at this point of time. So to accomplish all of these things, you need to deploy these models into edge devices or let's say low compute devices and without sacrificing on the accuracies or the performance. I think this is a very prominent area of research today. There are a lot of people, a lot of smart people across the globe working towards making these models smaller, easier to fit into the RAM of a machine, or basically trying to scale things down without causing a lot of performance hindrance. I think that's how we are going from this large language models into the area of small language models. I think from several billions or trillions of parameters, we have come down to let's say 7 billion parameters, a few 100 million parameter models, which are still able to give you decent amount of accuracy. It's not compromising too much on the accuracy. So that's one very strong area which I feel we'll want. I think going forward, there'll be a lot of new innovations in this particular aspect. We'll probably have models which will run on very low compute devices, even stuff like Raspberry Pis or Arduinos. We could envision AI powering a lot of new IoT applications through such kind of deployments being made possible. And the other thing about responsible AI and governance, I think today there is hardly a framework or governing principles or any sort of governance as far as training these AI models is concerned. So there have been a lot of efforts going on across the globe, across countries, in India as well, to regulate the sort of developments that are going on and ensure that we are progressing in the right way instead of just being haywire and training larger and larger models. And again, it ties back to the sustainable part of things. But also with governance, I think we'll be with more stronger governance coming into picture or more clearer governance coming to picture, we would want to focus on the responsible AI part of it, wherein we are using this technology in the right way. We are not causing harm through it because I think as there are two sides of a coin, so does AI have. You can use it for as good as purposes as possible, or you can use it for mass destruction as well. So, trying to see how these models can be grounded in facts instead of starting to hallucinate or provide wrong information, malicious information, or cause any sort of harm. I think those are things which are great areas of research, great areas of being introduced into future products. So, those are two key things that I envision. And another very interesting thing that I have been observing very recently is that this is lovely intersection of neuroscience and AI, which has been shining a lot these days. There have been several institutes across the world which have somehow been able to use deep learning models to visualize thoughts in your brain so that they can be shown to you on a screen. So we have actually achieved really good accuracies, really good performance metrics on various of these tasks as latest as July and August itself. I think so a couple of research papers were published just a few weeks back, which highlighted the fact that we are now able to use fMRI scans, these calcium scans, and a bunch of other things to actually process what you might be thinking at a given point of time and project it right in front of you. So think about if this technology is somehow merged with AR or VR or mixed reality of sorts, and then you are not only able to visualize what you're thinking, but let's say you are able to modify those things as well. So, for example, you may want to just do some interior decoration in your house, and you just start thinking about a thing, and that actual model comes in front of you. You can play around with it. You can change the color with a swipe. You can move things around here and there. I think that is totally something sci-fi, but with the amount of research and the amount of developments that are happening, I do envision something of that to be very, very likely in our hands in the upcoming in the recent few years.
That's wonderful, Tejan. Thank you so much for sharing all these wonderful insights with us. And folks who are watching this video, don't forget to check on all the links in the description below. And we'll be hosting another session with Tejan. Consider it like a part two. So stay tuned for that. And thank you once again, Tejan.
Thank you so much, Ravi, for having me on this podcast. It was really lovely to chat with you. I think, yeah. Thank you so much to the audience for staying tuned, and see you soon again.